Welcome to this explainer. Beneath all the massive 30th anniversary hype surrounding the Pokemon franchise right now, researchers at the Georgia Institute of Technology are actually using the game to tackle a gigantic problem in AI, real-world tactical decision-making. Today, we're diving into a genuinely fascinating study that uses this childhood classic to push the very boundaries of artificial general intelligence.
So we're going to track what is essentially the ultimate gamer's quest. We're following an AI agent named PokeLLM as it tries to overcome its own, frankly hilarious robotic flaws to achieve true human-level gameplay. The core goal here is super simple to grasp, but incredibly tough to execute. Can an AI mimic how a human player navigates complex, strategic battles and actually come out on top?
Now, you might be wondering why Pokemon? Well, researchers chose it because these tactical, turn-based battles can be perfectly translated into text without demanding any real-time physical reflexes. Unlike those fast-paced action games where an AI might win just by having superhuman digital reaction times, Pokemon totally removes the stress of twitchy gameplay mechanics. So performance here hinges entirely on the raw reasoning and strategic chops of the language model. The whole state of the battle, who's currently on the field, the available moves, exact health points, it's all losslessly parsed into a text description for the AI to literally just read.
And honestly, the AI isn't just playing some simple matching game. It has to instantly reason its way through over 1,000 unique species. And each one of those thousands of species has distinct characteristics, specific abilities, stats, and a massive pool of over 900 potential battle moves. While an experienced human player just intuitively knows right off the bat that a fire type absolutely dominates a grass type, the AI has to mathematically deduce this from scratch every single time it faces a randomly generated opponent.
And this crazy computational burden is exactly why standard LLMs completely collapse. They just get overwhelmed trying to track these tactical matchups inside a massive 18 by 18 elemental type matrix. Think about it. Every move, every Pokemon has an elemental type. Fire, water, grass, you name it. Some moves do double damage, some do half, and some do absolutely nothing at all. In just one single battle, the AI has to compare the types of all the opponent's Pokemon against its own, plus the types of all their combined moves.
Because they get so bogged down by this giant matrix of possibilities, raw LLMs suffer from fatal hallucinations, right there in the arena. In AI terms, a hallucination is basically when the model confidently states something that is completely, factually false. In a Pokemon battle, this means the AI mistakenly claims type advantages that don't exist, or worse, gets them completely backward. It'll just confidently send out a highly vulnerable grass-type Pokemon to fight a dominant fire type, making these terrible strategic blunders that literally cost them the match before it even really gets going.
When you actually test them against a basic, rule-based heuristic bot, the failure rate of these advanced models is just staggering. Check this out. GPT 3.5 only managed a 4% win rate, and even GPT-4, which is one of the most advanced models out there, only won 26% of its battles. Meanwhile, everyday human players were comfortably beating that exact same bot 60% of the time. Clearly, the AI was missing something really fundamental about human reasoning.
But it gets worse than just hallucinations. The researchers discovered this highly relatable, almost psychological flaw in the machine. When facing a really strong opponent, the AI exhibited this hilarious panic-switching phenomenon. It would literally overthink the threat and just constantly swap its team around, turn after turn, desperately trying to elude the battle instead of, actually attacking. This basically handed the opponent free turns to boost their own stats, which ultimately led to the AI's entire team getting wiped out. It mirrored human behavior so perfectly, overthinking a stressful situation so much that you just freeze up and fail to act.
So, to cure this hallucinating, panicking AI, the researchers stepped in and equipped it with 3 specific power-ups. These upgrades were specifically designed to bridge that massive gap between artificial processing and human tactical reasoning, ultimately evolving the model into PokeLLMon. Let's break down exactly how they pulled this off.
All right, power-up number 1 is in-context reinforcement learning, or ICRL. Now, this acts exactly like a human player reading the battle text on the screen to figure out what's going on. Normally, reinforcement learning means you have to feed an AI numeric rewards over thousands of hours of training. But because LLMs can already understand language, the researchers realized they could just use the text-based feedback popping up in the actual game as a completely new form of instant reward. So by instantly feeding the AI this text-based feedback, stuff about HP changes or how effective a move was, it can learn and adapt its strategy on the fly,
zero retraining required. For example, if the AI attacks a Pokemon and the game text says immune due to some special defensive ability, the AI reads that, realizes its strategy totally failed, and immediately pivots to a different attack on the very next turn. And just that instant adaptation alone boosted their win rate against the bot by 10%.
Moving on to the second power-up, this one tackles those early AI hallucinations head-on by essentially giving the model its very own built-in Pokédex. This strategy is known as knowledge-augmented generation. Remember how the AI would mistakenly send a grass type out against a fire type because it couldn't perfectly memorize that massive 18 by 18 matrix? Well, this completely removes the need for the AI to guess from memory. Instead of forcing the model to just guess, this upgrade retrieves external knowledge, like specific type advantages and really complex move effects, and injects it directly into the prompt right before the AI makes a decision. It perfectly simulates a human player opening up a wiki to look up unfamiliar Pokemon stats. By explicitly telling the AI, hey, Charizard is strong against grass-type Pokemon, the hallucinations just plummeted. And with this built-in encyclopedia, the AI's win rate against the bot absolutely skyrocketed to 58%. I mean, that puts it right on the doorstep of human-level performance.
Finally, we have power-up number 3. To cure the AI's nasty habit of panic switching against intimidating opponents, they brought in consistent action generation. See, the researchers noticed that when they asked the AI to use chain-of-thought reasoning, which is where it explicitly analyzes the situation step by step before doing anything, the AI would actually overanalyze the danger, totally freak out, and constantly swap out its Pokemon to run away.
So instead of relying on that deep, overcomplicated chain-of-thought reasoning that ends up paralyzing it, the researchers flipped the script. The AI now independently generates multiple different potential actions all at once and simply votes for the most consistent one to execute. By basically silencing that long-winded internal monologue, the AI cured its own panic, stopped the endless swapping, and kept its focus squarely on fighting the opponent right in front of it.
Okay, so with all 3 power-ups fully equipped, instant learning from text feedback, an external Pokédex for perfect knowledge, and consistent voting to stop the panic, PokeLLMon was finally ready. It entered the ultimate arena, online competitive battles against highly disciplined, real human players on an official matchmaking server. We're not playing against a predictable, coded bot anymore. This is facing human creativity, wild attrition strategies, and deceptive tricks.
And wow, the results were absolutely incredible. Playing against completely random, real human opponents on the internet, the AI achieved a super impressive 49% win rate in standard ladder competitions. It wasn't just getting lucky, it was executing sophisticated, human-like strategies, perfectly timing complex defensive moves, and navigating a really chaotic battlefield with incredible precision.
But it gets even better. In invited battles against specific players, it actually peaked at a 56% win rate. With this, the researchers officially proved that by combining a large language model with these 3 specific environmental interactions, this AI agent had leveled up to achieve true human parity in a tactical battle game. It wasn't just spitting out text anymore, it was independently making complex, real-time strategic decisions to actively outsmart human beings.
So, I want to leave you with this final thought today. This explainer isn't really just about a nostalgic video game. It's about how we can actually take language models out of the chat box and teach them to autonomously navigate highly complex environments. If an AI can conquer the chaotic, tactical depth of a Pokemon battle by learning on the fly, retrieving specific knowledge, and keeping its cool under pressure, what complex, physical world puzzles will it be autonomously solving next? The ultimate quest for artificial general intelligence has officially entered the arena.